19 remarkable duty has been performed by them.
Okay.
Yes, sir. So
Very nice. So you have quite a few people I see with different
yeah,
backgrounds. It's a good collection of people telling you different hazards. What is the situation?
right, sir. We try to contact or cover different types of disasters, and we contacted different areas of the country. So I think we are lucky to have good support from all of
Yeah.
them. Sir.
Very nice.
So we are starting within just
Yeah, sure. Yeah, I
3-4
understand.
minutes. Sir.
3:30. Yeah, 3:30 we'll start after that.
Yes, 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 sir. Yes, sir.
Yeah.
Right now, one more training program is going on at GIDM. It is on. It is with the engineers from Server Shiksha.
Okay.
The school safety is the priority in that. Yeah, yes, sir.
Can you develop a procedure for school safety assessment, structural safety as well as non-structural safety? Because the national school safety guideline is not talking
right.
about the structural safety.
Okay, sir.
NDMA doesn't have the school safety, structural safety guideline. It has non-structural safety as well as preparedness guideline. How to assess the buildings of a school and how to retrofit them, that is
Okay,
not
sir.
there. So what we
Okay.
could do is, if you can identify a small single-story school which is masonry,
Right, sir.
we can retrofit that in a day's time and
Okay.
come out of it. That is what I was thinking.
Right, sir. Sir,
If
tomorrow,
you
day
can
after
talk to
tomorrow.
somebody, some school authority, and get one masonry building, brick masonry building,
Okay, sir.
and let us retrofit that in 1 day's time. If you send me the drawing ahead, I'll tell you what material is required, and
Okay.
we'll do it in a day's time.
Sure, sir. We can do that. Definitely, we can do that. And tomorrow we have actually this rapid visual assessment. Actual school.
Find a masonry school which doesn't have lintel bands,
And yeah,
and we can
and
fix it in 1 day's time.
okay, right, sir. We, we can do that, sir. And sir, what you said that the process, the rapid visual assessment, that guideline is not there. Is it so?
But see, assessment, if you're looking at the classical level 4 assessment, that can be a very slow process, even for one building. They will ask you what is the material strength. Then you will pull out some bricks from the building, go to some lab, and you have to pull out enough number of bricks so that there is a statistical set. Right? Sometimes the buildings are so old and the bricks are so weak that when you pull out some bricks, then you're causing damage to the structure. So my approach is, as of now, if there's a masonry school which doesn't have lintel bands, we don't have to do any assessment. We just have to do retrofit. Good afternoon, madam. You are muted. You are muted. No, I can't hear you.
Department, you are muted. Yeah.
Yeah, now we can.
Good afternoon, sir. STTP. Yeah, and everyone is eagerly waiting for your session. So we'll start in a minute. We had a previous lecture, little straight out.
I'm not able to hear you, madam. There's the voice is cracking in between. I'm wondering if there's an issue with bandwidth.
Okay.
Even the image is coming intermittently in jerks.
Okay, sir. Okay, sir. Is it better?
Still the audio clarity is not there. Chetan bhai, are you able
Your
to hear
image
me
is very
clearly?
clear.
No, the audio clarity is not there. Your voice is breaking. Yeah.
Okay, sir, we can start. We can start, sir.
How many participants are there in total?
In total, sir, we have regular about 57 participants.
So
A
we have
previous
only
session.
about 20 are in the meeting right now.
20, yes, sir, 28 are there. And sir, they will join immediately. I have put myself because the previous session had been stretched little bit. We are delaying
Okay.
behind the schedule.
If you want to wait for a minute or two, that's fine with me, not an issue.
Please, sir, please. 2 minutes.
But if you want to start, we can start. I have no problem. We can start also.
2 minutes, sir. 2 minutes. Yes, sir. We may start, sir.
Okay. So can I start?
Sir, 1 second. 1 second, sir. Sir, we need to give you a proper introduction to everyone, one and all, to appreciate your gracing our occasion. So, plus 1 second. I invite Rushit to have your esteemed introduction. Rushit, over to you, please.
Hello, am I audible?
Yes, you are.
Hello, namaste. Good afternoon to one and all present here. I, Rushit Chaudhary, on behalf of the Applied Mechanics Department, LD College of Engineering, Ahmedabad, and Government Engineering College, Madras, welcome you once again for the third session of the fourth day of this 5-day short-term training program on disaster management and resilience building conducted under the aegis of Directorate of Technical Education in collaboration with Gujarat Institute of Disaster Management, Gandhinagar. I feel honored to introduce you all to the rewarded personality we are having today with us. We have Dr. C.V.R. Murty, sir, Indian Institute Chair Professor, Department of Civil Engineering, IIT Madras. Dr. Murty, sir, did BTech in Civil Engineering and MTech with a specialization in Structural Engineering from the Indian Institute of Technology, Madras, India, and a PhD degree with a specialization in Earthquake Engineering from California Institute of Technology, USA. Sir has vast experience in the earthquake field. Sir has a great command to non-linear structure analysis and ductile design of reinforced concrete and steel building and bridges. Sir's primary research and development interests are in non-linear earthquake behavior of buildings and bridges towards developing displacement-based and energy-based earthquake resistance design. Sir has authored and co-authored 6 books on earthquake resistant design and construction. Sir is the chairman of the Earthquake Engineering Committee of Bureau of Indian Standard BIS and steering a comprehensive upgrade of the earthquake design standards of India. Sir has also received the 2018 ICI Best Paper Award and Best paper published in ICI journal limiting twisting during earthquake in building with unsymmetrical stiffness in plan elastic study at Indian Concrete Institute 2018. I would like to request Dr. C.V.R. Murty sir to grace us with his knowledge on the concept of R&D in earthquake disaster management. Over to you, sir.
Thank you, Rashid Chaudhary. Good afternoon, ladies and gentlemen, respected colleagues and dear students. The subject given to me today is R&D in earthquake engineering, and I'll with that. If India needs to be earthquake resilient, first change that we need in ourselves is safety. We need to put safety on the driving seat. Second change we need in ourselves is that we need to learn the subject and implement the subject. The third is that there is a nation with 140 crores people, and 80% of the land area is under the threat of moderate to severe shaking, which means that we're looking at about 110 crore people under the gamut of earthquake shaking. To service or to help 110 crore people, we need large number of engineers, artisans to participate in this activity. And so we need a comprehensive capacity development. Capacity development here means teaching the subject to people and helping them implement that subject. Now, it so happens that as we are speaking today, no college teaches this subject as part of the mandatory curriculum at the undergraduate level. And if that is the truth, then we have a long way to go. Second, the market is becoming very aggressive. They are bringing in technologies that are not tested, and they are claiming that they are earthquake resistant, and thereby the nation is in trouble by use of this untested technologies. So the next change that we have to mandatorily make is that we have to use only tested technologies. And the most important activity as we look at it today is that 10,000 municipalities, none of them are checking the safety of the structure when a design document is submitted to the municipal corporation. So on 3 counts where we are using untested technologies, where the designs are not being examined by municipalities, and where engineers are not competent enough to handle the subject of earthquake engineering, we are looking at a backdrop of R&D, which is the basis of creating evidence-based implementation of earthquake resistant design practices. We are looking at Gujarat's 2001 earthquake, where building collapsed and they're rebuilding again, this time also without earthquake resistant features. Like this, there are large number of buildings that are cracked and standing in the country, across the country, which need urgent help for retrofit. We are looking at a good number of structures that are hybrid structures made of different materials, be it brick and reinforced concrete, or brick and wood, or stone and wood, and so on. So we need a formal program to study all these technologies. We also need to worry about the so-called engineered structures as well as the non-engineered structures. And there's much more gain or development we can achieve quickly if we can sort out the construction of the non-engineered construction. So-called contractor-driven construction is making mistakes, which is becoming very obvious in the aftermath of earthquakes. So the type designs are a big crisis for us. It is easy for a government or a contractor to take a type design and reproduce 50,000 of them, or 10 lakhs of them, or 8,000 of them. But If there is a mistake in that, if that technology is not verified adequately, we will be embarrassed as we have been in the past. If engineered buildings collapse at moderate shaking, we are in a position to say that we have not done enough to protect our own cells. Look at the spectrum of structures, bridges. Over 3 lakh bridges are sitting across the country, which are made of masonry structures, and they need urgent help. Large number of buildings and structures already built, but without earthquake resilient features are potential dangers for us in the next big earthquake that is likely to happen. If one thought earthquake engineering was a civil engineering activity, even that is not true. And so virtually all engineers have to worry about earthquake shaking, be it electronics engineers, electrical engineers, mechanical engineers, and metallurgists, material science people. Everybody should now find agenda, and there is enough work for each of them to get worried about the next big earthquake. Community structures have not received enough attention, especially water tanks. And we need to make sure that we don't have this practice of making cheap structures, but we develop a practice of making safe structures. Coastal structures, we don't have any standard for design of coastal structures to resist earthquakes. This is a double jeopardy problem because as such they are in water and there is clay and piles. In addition, if you add a shaking to that, then you're looking at possible liquefaction also to occur, even though it is, in clay. There is a need to examine that. Industrial structures come with their own complexities, and enough study is not being done to say that the designs that we are providing today are good for lateral actions. They may be good for vertical load carrying capacities, but not necessarily for lateral actions. It should become a practice in the nation that when you have irregular structures, the new engineers who are coming in from the colleges should be prohibited from designing such structures because the nuances are one too many and the complications are such that even an experienced engineer needs to spend significant amount of time, effort, and consultation before approving the design of such structures. It is embarrassing for academia in the country to take pictures like this, where the simplest example that we teach in class is not being implemented such that it can resist the effects of earthquakes, a single degree of freedom system. Multi-story buildings will continue to collapse if we do not address the points in two-pronged approach. One is make sure that the new structures are made safe. And second is to make sure that the existing structures are retrofitted urgently. We are having certain practices in the field where we suddenly reduce the column size at an intermediate level, and that tells us that that practice needs to be discontinued because it is doing a sudden change in stiffness and strength at that story. So in effect, how do we go about doing this entire work? When I look at disaster management per se, there are events, 3 of them before the disaster strikes and 3 of them after the disaster strikes. The most important, where we will get the maximum gains for the same effort, will be when we address the matters of mitigation and preparedness. Those of us who understand the 6 pillars, it's fine. For the rest of you, mitigation means building the hard structures to stand there without collapsing. So this is about the built environment. And preparedness is about the people, getting them ready to behave in a correct way when there is earthquake shaking. You would agree that if we build all the structures to be safe from earthquake shaking, then you don't need response, you don't need rehabilitation and reconstruction. Post-earthquake response, you don't need. But if you don't do anything before the earthquake, which is mitigation and preparedness, then we will continue to have losses of lives and significant setback in property losses, and the nation will be pushed back, the states will be pushed back 30, 40 years every time there's an earthquake. This is something that we need to introspect deeply on. So what is the method of going from where we are today and where we need to go, the target for us? There are two options. One is we're looking for ladders and we want to go up quickly. You want to do large work in half an hour and then reach there. The other one is go along the dangerous path for some time and then you'll soon see that life will get simpler and then you can walk ahead on a safe trajectory. So we need to do small little work every day, all the time. The first approach is the post-earthquake approach, which is response, rehabilitation, and reconstruction. And the second approach is mitigation and preparedness approach. Once mitigation is in place, preparedness has meaning. But if mitigation is not there, just doing preparedness will actually bring not much gains to the nation. When you look at disasters, there are small events which are local, can be handled without much pressure on us, but there are events that can spread over a state. Then there are events that spread over a nation, and then there are events that spread across the boundaries of the international borders. And hence, we need to see where is the potential source of earthquakes for us. Are we going to be incapacitated inside in a local town alone or in a state, nation, or international? It so happens that unlike other disasters, earthquakes do not happen in towns and cities. They happen in regions, and hence it can be within a state or across states or within a nation or even across international borders, as we have seen in the past earthquakes in India. So we need to prepare ourselves not for the small event alone, but for the largest event that is likely to happen in the country and bring together people of that region to become that much more capable. So we need a graded capability across the country to resist the issues of earthquake resistance. So there are three things, three sets of activities or focus areas for us. First focus area is people, second focus area is property, and third focus area is performance. If your people know what to do, they can build the structures correctly, and if they build, design and build the structures correctly, they will perform correctly during the earthquakes. Now this is where the catch is that even though we know the sequence 1, 2, 3, it is interesting that unless you bring all the people together, academia, industry, and government, and ensure that the property is protected, the rest of it is not going to bring us gains. So once the property is protected, you will realize that it is possible that we can improve the understanding of the people, and we can also improve the performance of the structures in the next earthquake. And this loop is possible only when an R&D, an organized R&D program is organized in the country, which brings together this three tripod of academia, industry, and government together to take responsibility of facing the next earthquake without any human losses. If I come down particularly to earthquake disaster mitigation, we can look at the entire effort of earthquake disaster mitigation in 15 items. One is to document typologies of all the structures that we have: buildings, bridges, water tanks. We have retaining walls, chimneys, silos, bunkers, and other spectrum of structure, bridges, and so on. Now, on the education side, we are looking at manuals for good practice, and we're looking at technical education. On the safety side, we need to outlaw unsafe typologies and come up with new technologies to construct the structures better. Very clearly, a habit that we haven't created is full-scale testing in the country. We seem to think that on paper, if we work and do some calculations, the structures become safe. That is not true. All the designs that we are doing today have been verified in some country through a detailed R&D program. But if you're coming up with new technologies, if you don't do detailed R&D program and demonstrate safety through full-scale testing, then we are actually putting our own lives in danger. When I look at practice, we need to develop skills in the artisans. We need to do continuing education of the engineers and architects who are practicing. We need to retrofit existing structures, and we need to build new standards and update existing standards to better reflect the state of the art and the state of the practice, at least, which is happening elsewhere in the world. On the policy side, we need to change our bylaws very regularly to keep track of unsafe options that exist in the current bylaws. And this can happen only if we are able to license our engineers. And as I said, in the 10,000 municipalities, when no municipality checks the design, then we need to bring in this third-party peer review system for structural designs to be assessed and said whether it is safe or not. To make sure that the limited resources that we have today and to prioritize the work across the country, we need to have risk indexing, which tells us the relative risk between different locations and different states. And we can prioritize our resources, including financial and human resources, to be allocated proportionally depending on the relative risk that we are faced with. Clearly, there is need for a legal arrangement so that structural safety will see lots more respect and dignity in time ahead. When you look at all of these activities, you recognize that the center two activities, which is safety and practice, are largely driven by industry. The policy is largely driven by government, and typology and education is largely driven by academia. When you look at any one item, it is not true that the corresponding primary responsibility holder alone will solve that problem. For example, if you want to do full-scale testing, industry may be able to set up a test facility, but academia has to come in and say that this is how testing is done. And government has to say that once you do full-scale testing, we should accept the technologies after successful test of the technology. So in every of these boxes, there is a need for all the three to come together, academia, industry, and government, even though there is primary responsibility assigned to each of them. Only then we can say that we will have a competent nation capable of undertaking earthquake disaster mitigation. Right? Now you might ask, in this picture, where is R&D? R&D is in every of these boxes. Right? It is not that R&D is a separate holy cow, which we will have to address independently. But if you're looking at technical education, unless the teacher knows 100, he cannot or she cannot teach 10. Right? Unless the rigorous analyses are done and the unsafe typologies are demonstrated, we cannot remove the unsafe typologies from practice just by word of mouth. We have to demonstrate their poor performance, and we just can't wait for the next earthquake. We can, if we have it on the previous earthquake, it is wonderful. If not, we have to do detailed experimental as well as analytical work to show that we need to remove those unsafe typologies. Very clearly, so what is the roadmap for built environment? R&D tells us that first of all, the construction should be minimal. If you don't want something, don't use that, don't make that. So don't make unduly large buildings and tall buildings and wide buildings and with a large number of fixtures, with heavy masses and so on. So you need to use minimal resources and make a structure. First. Second, you need to use natural materials to the extent possible to make a structure. Third, you need to understand disaster resistance and build those disaster resilient features in the constructions. And fourth, you have to respect nature. Every time the solution is not to defy nature, but it is very clearly in some cases you need to comply with nature. And this is where the displacement design and the force design comes into picture. Structural safety, on the other hand, if you look at it, it has 5 major expectations: safety, serviceability, durability, aesthetics, and economy. These are the 5 tenets of every built environment. And out of these, on the driving seat should be safety. On the top of the list should be safety. Once safety is in place, then we will assess serviceability, durability, aesthetics, and economy. Furthermore, the first 3 are fixed in that order. First of all, it has to be safe. Second, it has to serve the needs, the functionalities that we have. And third, it has to be durable. And only when it is serviceable, then only we can talk of durability. Otherwise, we do not talk of durability without it being serviceable. Also, the last 2 items, aesthetics and economy, are something that we will have to keep in mind. Every engineering solution should be an economic solution. So unduly increasing cost of structures just because we get a percentage of it is not the method of life for any designer who is building these structures, right? Aesthetics, if you want to make the building more aesthetic, you may have to spend a little more money. Or if you don't have that much money, you can push aesthetics down and bring economy up on priority list. Otherwise, the first 3 positions are fixed and we need to comply with that. Wisdom tells us that on earthquake disaster mitigation in the R&D side, we have made many mistakes and we don't want to make those mistakes now. So what are the mistakes that we made in the past? First of all, we don't have trained manpower. So the first requirement of R&D is that we have trained manpower. Qualified manpower is not sufficient. We need competent manpower. Competence is knowledge plus skill plus positive attitude. Only then we call that as competent person. And so we need competent manpower. Second, we are undertaking land use indiscriminately. For example, if there are low-lying areas, we go ahead and construct structures in that. And when earthquake comes, because of the water table being very high in those low-lying areas, liquefaction happens and the structures get into trouble. Or if you're on the hill slopes, which are unstable hill slopes, rolling debris will come and hit the buildings. And then we are saying, no, this is unsafe. So we need to worry about land use the way we have been using land. And sometimes in hilly areas, we are overloading the slopes, and settlements are now becoming very obvious in 60 years' time that it was not a good practice to overload the slopes. Third, we are very excited about using high-grade materials, and we know that high-grade materials are not good for us. And unless they are adequately researched and rehearsed, we will not be able to ensure that or a guarantee that high strength materials means higher safety. Also, technology that is not verified experimentally is not technology. It is only a thought, and we just can't implement thoughts. We have to implement technology. So analytical and experimental verification is mandatory for us. And finally, we're looking at compliance. We are not complying with the standards. And if we are complying with the standards, nobody is checking our designs. And so there is no guarantee, no assurance that we are actually complying with the standards. Right. So where do we begin in this very difficult situation? Where do we begin? We have to make an imperfect start. And the imperfect start is that we will have 80% of our effort should be to apply available knowledge and make sure that we make good progress. About 15% should be to adapt available knowledge to the Indian conditions. And finally, only about 5% is required to generate new knowledge required for earthquake safety in the country. All these 3 together can be viewed in a very clear platform where we are able to say that 80% progress can be made if we have good education in the subject of earthquake engineering. Second, 15% progress can be made by available knowledge being applied to the Indian conditions, and that we are calling it as development. Simply applying available knowledge and modifying it to suit our needs is called development. And finally, the extra knowledge that we need to develop for Indian needs is the research part of it. And we have a good list of activities for all of them. On the research side today, as we are speaking, we need to understand the earthquake hazard much more clearly than we understand today. Most of the country still thinks earthquake is applying a force on buildings or structures, while that is not true. Earthquake is actually imposing displacement under the structure and forces are induced as a consequence. So if you design the structure with different properties like initial stiffness or strength, you will get a different response. And hence, there is a need to completely understand earthquake hazard in the context of the actual shaking of the ground. Second, as I said, full-scale testing is not been in the eyes of anybody in the country, but we are going ahead and building large number of structures with especially the three pre's that we have, which is precast, pre-stressed, and pre-engineered, are dangerous practices for the nation. We just can't go ahead and construct without demonstrating that they are safe. Third, seismic design has evolved over time, and we need to look at how to provide this design engineering for further improving the behavior of structures. Today, we have torsionally irregular buildings being constructed across the country just because functionally they are exciting. The fourth and the very important activity is seismic retrofitting of the houses of the masses of India, which are largely single-story houses and largely masonry houses. And we need to fix those houses so that we are able to retrofit and save their lives immediately. Indian standards have been rather infrequently upgraded, and which is not the practice elsewhere in countries with advanced provisions for earthquake safety. We're typically looking at 3 to 6 year cycles for revising the standards in those countries. But in India, we are looking at decades and still the quality of the upgrades are much wanted. When I look at the on the education side, technical education, we don't have enough teachers who can teach. And so my worry is who are the people who will do research in this country if you don't know the subject yourself? And if you don't know the subject, how will you graduate students who know the subject? And so who will practice earthquake resistant design in the country? The nation has to now look at it in a very different context where they will wake up and introduce earthquake safety, earthquake resistant design, earthquake engineering in the education practice of the nation. Talking about hazard, as I mentioned before, we have looked at all our 16 load actions that we have. And when you classify them, you have the non-random loads and the random loads classified into force loads and displacement loads. The force loads are relatively well understood, but the displacement load, which is earthquake loading as well as foundation settlement, elastic shortening, temperature creep and shrinkage are not well understood. They are not taught in the classes also. And this is where the worry is that we send out people with force load design capabilities and they have to implement displacement loading design at the practice level. Another important point is that when you look at force loads, there is a sense of characteristic load where 95% of the cases, the load is more than that characteristic. The load is less than that characteristic value. And that's not the story in the case of earthquakes. They are relatively infrequent activities. So we need to play around with the probabilities of succeedance. So unlike in the case of the commonly known loads, where the design loads are characteristic values, in case of earthquakes, the design loads are not characteristic values, they are considered values, which means that it is becoming subjective here. Just to tell you an example of how subjective it can be, the matter here is that we have buildings where damage is allowed, then we have important structures like hospitals where not so much damage can be allowed. And then we have the third set, which is a critical facilities like transport, water, power, gas, and so on, in which even lesser damage is allowed. And then there is this special set of dams and nuclear power plants in which we will not allow any damage. So the question is, if the white line is the hazard curve, what should be the probability that has to be used for the design of this structure? What should be the probability of exceedance? No formal work has been done in the subject, and so there is enough R&D to be done to make sure that this is undertaken urgently. When you look at the Indian continent, subcontinent carefully, you will notice that there is a very special situation that we are faced with, which is the Himalayas. And when you're looking at Himalayas, the faults are along the Himalayas, and there is a near field action that is causing the faults to provide large velocities and large displacements in the ground motion, which are residual displacements. And this is not reflected in the current design practice in the country. So there is a need for understanding fault normal and fault parallel motions, which will eventually tell us what will be the design approach to face large movements in the proximity of faults in the country. Seismic hazard assessment has yet another dimension for India, which is peculiar to this nation or not to other nations. And that is, when you look at the northern region here, we have the Indo-Gangetic Plains, which is largely the ocean bottom sand that has come up due to the plate collision. When Indian plate collided with Eurasia, that is the ocean bottom material that has come up. And this ocean bottom material changes the response of the ground depending on where exactly you are located with respect to the fault lines, right? There are deeper sections near Gorakhpur, which will be about 5-6 kilometers thick. And there'll be sections near Lucknow, which will be about 4 kilometers thick. And then there are places in between like Kanpur and then eventually Jabalpur, where you're looking at the sediment thickness varying from 6 kilometers to 0 kilometers. Different structures respond to different natural frequencies in a different way. And hence, we are looking at understanding the site period carefully so that such structures whose natural periods come close to the site periods need to be designed in a different way altogether. And so we need regulations here, but for that regulations, we need to have enough R&D undertaken so that it will go forward safely from where we stand today. The concept of multi-hazard has been in use all these days. I must say that just as in design, when you design a structure, you first design it for strength and then check for serviceability and robustness and integrity. In the same way, you need to look at your primary hazard that is prevalent at a site. Let us say there is a location where earthquake is the primary hazard in the country. Then you need to design for dead load, live load, and earthquake to begin with, and then check for all the other hazards and all the other levels of performance that you're expecting. So it is not that this is something new that we are doing today. This has been in practice all these years. It is just that somebody managed to put in an exciting word into the government's eyes and they called it multi-hazard. Every design is actually supposed to be multi-hazard. There is no design that is not multi-hazard. And so we have to be very careful in trying to look at buzzwords that are going in market. Don't fall a prey to this multi-hazard story because this is not a new story. We have been doing this all along. Disaster resistant design, as I said, when you look at multiple hazards, there is defined design if you look at force loading, and there is compliant design if you are looking at displacement loading. And this is where we stand today, that always larger sizes, thicker members, bigger structures is not going to win you safety, because larger structures, bigger sizes, thicker members will give you more mass, and that will mean more earthquake forces, which means there is a need for higher earthquake resistance. And especially if your material is weak like masonry, they will not survive. History is a testimony that dynasties have collapsed because of the falling down of masonry structures just because of their high weight and low strength characteristic. So nature is right, and nature is right always. We need to learn so much more from nature. What it means is go around the country where you have earthquake shaking and see what are the traditional constructions that are happening over the years and see why those traditional constructions are surviving. And this is where extra R&D is required to make sure that we appreciate the fine details and the finer designs that are prevalent in vernacular construction, which have come down over centuries and which have lasted over centuries. So this is the first time that you will realize that if you know the materials and you design the sections and then detail the members and go ahead and construct, it is not sufficient. You need to also understand the behavior of the structure that you have designed, and only then you should sign on the drawings. So just the forward loop is not sufficient. You need to close the loop and make sure you always follow a closed loop design method. Currently, Indian practice is not doing the closed loop design method, and we need to go towards a closed loop design method, which means good amount of R&D needs to be done by the people of India, by the technical people of India, by the competent technical people of India, by a large number of competent technical people of India, by a graded of all ages, large number of technically competent people of India. That is what I'm looking at. When I say graded, I need people who are young, who are middle-aged, and who are old-aged. All ages, we need R&D as a sensibility, R&D as an excitement, R&D as a responsibility to make ourselves safe from the next earthquake. So to be wanting to do R&D, you will recognize that R&D can be done on any of the 7 virtues of earthquake-resistant construction. What's the first one is on configuration. You can interact with architects and come up with a detailed structural analysis on the effect of form on safety as far as the architectural practice is concerned. So that's the first one. Second one is how stiff should be the structure in its initial undamaged state. Third is what should be the strengths that you should impose to ensure in these structures. Fourth is what should be the ductility that we can have in these structures? Indeed, what is the ductility that can be achieved in these structures? Fifth is what is the deformability of these structures? How much will they shake back and forth without collapsing? That deformation is important because earthquake is only applying deformation. So ultimately, if your structure has to stand, your deformation capacity has to be more than deformation demand from the earthquakes. And sixth is that there is a collapse mechanism. The one that you see on the top here is the desirable collapse mechanism, let's say for buildings where only beam ends will form plastic hinges and all the beam ends will form plastic hinges. The current design practice, all the beams are not forming plastic hinges, only in the bottom third or bottom half the plastic hinges are forming, and the top half is just sitting joblessly doing nothing for the nation. And so we have to make sure that the plastic hinges form throughout the height, and then only we say that we are able to make sure that all the citizens of India are participating in the safety. Like that, all the members of the building are participating in earthquake resistance. And the 7th item is to see how much energy the earthquake is feeding and how much energy can the structure absorb. So 7 levels of R&D can be done as of today, and we are at the starting blocks. That's the good news as well as the bad news. The bad news is because we haven't done much, but the good news is we can do so much from today. So when you took out design methods, if you have seen past design methods, stiffness-based design was what was done in the yesteryears, masonry structures, but that was discontinued, and we got into strength-based design. And that strength-based design is the current practice now, but significant effort is underway on deformation-based design, and this will become eventually the norm for new constructions. And I'm hoping that many of us in India will learn this subject. And eventually, we also have to walk towards energy-based design. And just research is beginning in the energy-based design, and we need to focus on collapse mechanisms, deformability, and energy absorb to ensure safety of the people of India. When you look at vulnerability of the structures under the three dominant effects, natural effects on structures, you're looking at wind, which generally carries the structure away in the upward direction, right? Everything flies in wind. Under flood action, everything topples, and under earthquake action, everything collapses. And these are the three actions that we'll have to design for. Interestingly, if things are flying away upwards, the recommendation is you should have large mass and good anchorage. Interestingly, for flood, to prevent it from toppling, the recommendation is large mass and a wide base so that it can be restricted from toppling. And interestingly, earthquake requires small mass, right? So now if you're doing multi-hazard design, tell me what should be the mass of the structure. And this is the subject of R&D. If earthquake says small mass and all other fellows are saying large mass, earthquake is not wrong, neither are the others wrong. Now it is for you to make things right as to what should be the mass of the structure to design it to resist earthquake effects. Indian standards today, only a limited number of them on earthquake safety, about 10 of them out of the 2000 standards that we have for buildings, and 400 of them are related to safety. Only about 10 of them are related to earthquake resistance, right? And we know those numbers also. And some are related to hazard, some are design, and some are assessment retrofit. But these are the early provisions, and we need to make a comprehensive upgrade of this. And this is where we need a lot more participation of people who are doing R&D, because clauses can go in and can make India safe only if they're adequately researched and rehearsed in the laboratories and tested before they are practiced, right? So in particular, the role of practicing engineers to become professionals, truly professionals, in terms of trying to guide the R&D efforts is what we are expecting in time ahead. Right. Once again, back to our three dominant natural effects. Wind is seasonal, flood is annual, earthquake is rare. So what are we doing? Wind, we are doing something because it's, it's our regular headache. So we are addressing it to some extent. Flood, interesting. We are constructing in lower lying areas. That means we are absolutely foolish in trying to use land wherever it is available and then cry loud saying that, oh, it has flooded and now disaster management and so on. Absolutely ridiculous, lack of common sense practice. We need to discontinue this immediately. You have to stay well below well above high flood level if you really want to be safe in the next earthquake, which all means that you need good public transportation system. People need not all live on the edge of the waters. Some of them can be inside, and they can be provided water from where we have. But what is embarrassing is that we are not fearing anything as far as earthquakes are concerned. And despite past experiences, we are still playing dangerous with no education, no professional competence, and no checking of the designs in the country, right? Very, very unfortunate. So when you look at the gap areas very clearly, wind, you want elastic behavior, and earthquake, you can permit inelastic behavior. And what is clear is that while there is an upper load for the force loads that we know of, 10 of them, there is no guarantee of an upper limit on the displacement loading, but that can be determined only probabilistically and not so deterministically that we do in the case of force loads. Also, main gap area that we're looking for is nonlinear behavior of structures. And today, nonlinear behavior is not taught in the country, again, as part of the mandatory curriculum in any of the master's or PhD program. That is where we don't have teachers to teach them. And so graduates will not know. They'll continue to press buttons on computer software that's available in the market and draw graphs, which mean nothing to them, and they can interpret it any way they want. So this is an embarrassing moment again. R&D has to grow in this direction. When you look at exposure, we talked about hazard, we talked about vulnerability, and now we're talking about exposure. Exposure is from different points of view: people, property, downtime of various services and activities, and business. So we're talking about human exposure, property exposure, financial exposure, and business exposure. All of these hazard, vulnerability, and exposure together need to be contained, and bylaws will play an important role in this. Together, hazard, vulnerability, and exposure is called risk, and hazard largely is understood through earthquake science, vulnerabilities through earthquake structural engineering and geotechnical engineering, and then exposure is through bylaws. And if you can contain all of these within the safe limits, you will walk towards ensuring structural safety in the country. As of today, we have very high risk under the likely probable loads. We are getting a large amount of unacceptable and intolerable levels of damage in structures, as was seen in the 2001 Gujarat earthquake. We need to reduce that and increase the possibility of acceptable and tolerable damage in structures under improbable and possible loads. This is where the game is, and I'm hoping that we will spend enough attention in the decade ahead on assessing risk in the country. We don't have many organizations, in fact, forget about organizations, we don't have many hands that can do earthquake risk assessment in this country for what supporting the needs of 110 crores who are sitting in seismic zones 3, 4, and 5 in the country. Furthermore, we need different competencies for designing these different structures that we have, the spectrum of structures. And the rigor only increases as you go towards the right, where from normal buildings to tall buildings to water tanks to bridges to chimneys to pipelines to dams to nuclear power plants, we need higher and higher levels of rigor, and we don't have those hands in the country to handle these in a specialized way with deeper understanding of the subject. Right? Talking of technology, we have about 5,000 such dams in the country, but when you look at the dam assessment, safety assessment, 3 activities are required: field tests, analytical studies, and laboratory studies. Very clearly, there are no field tests done and no laboratory tests done. Only 1 or 2 individuals are doing some analytical work in the country to protect 5,000 dams. And even in analytical work, the people who are doing such work are only doing the 1960s equivalent static analysis, and maybe in a limited case, they're doing the finite element analysis, but linear behavior. And hence, we are in great need for a large number of hands which can handle the subject of safety assessment of the dams, especially the 5,500 specified dams in the country. As I said, today we have over 320 or 32 crore buildings and an equally large number of other structures in the country. We are looking at making sure that all the new constructions are made safe in time ahead by improved education, improved research and development, and improved professional practice and peer review verification. That is the only multi-pronged approach that can take us to make structures safe. But how about all those structures that exist right now? If you have to bring them into the realm of safety, then you need to retrofit them. And so the number of unsafe structures have to be reduced over time. And we are praying that we will be able to do that quickly. If we don't, then the earthquake will win the competition and we will be embarrassed once more. So we need technologies for retrofitting and different technologies for different structures: critical structures, lifeline structures, schools, and select houses and buildings, which are required, especially after the earthquakes. Assessment today, earthquake safety assessment of structures, has to be understood in the context of 4 levels of assessment. The first 2 levels are called the qualitative assessments, and the second 2 levels are called quantitative assessments. Anybody who has done qualitative assessment and said that the structure is safe or unsafe should not be believed. Only when they do quantitative assessment is when the game begins, and that is where we are looking for more attention and effort in R&D, where we will require to spend the time on details and bring about clear statements on how to ensure safety of the structures, right? I suggest that we could begin with level 3, which is simple quantitative assessment of all structures that I showed you so far. So when you look at the 4 levels of assessment, the first one is it takes less rigor and less time. Second one, more rigor and little more time. Third one, even more rigorous and much more time. And then, of course, the level 4 is deep details and large amount of time. If you can do 1,000 buildings, you can do 100 buildings in the same time with the same people. You can do 10 buildings only of level 3 in the same time with the same people, and only 1 building you can do in the same time with this full rigor. What we are saying is that when you take a stock of 30 crores of buildings that exist, of which 25 crores are sitting in seismic zones 3, 4, and 5, if you want to assess them, you can't do level 3 assessment for all of them. So the importance of level 1 and level 2 is to simply filter out or prioritize structures so that we can do level 3 and level 4 only for the important and high risk structures that we have. There are a number of techniques for retrofitting, but in the market, there are a good number of people who are selling repair as retrofit, and that is where I would like to caution you that don't get unduly carried away by repair as retrofit. Please know that you are able to clearly appreciate the difference between repair and retrofit, and don't just use the word repair loosely when it comes to earthquake safety. In fact, I would never think that there is a word called repair in earthquake safety, because there's always retrofit. That is the one that talks about structural safety, that talks about all the 7 virtues that we just showed you a moment ago. So the retrofit is a very clear set out procedure, and you need to undertake that in a rigorous way, in an organized way. Only then we can say that we are on the roadmap for making existing structures safe. Now, this is where there is opportunity for the new generation. We have created a large stock of unsafe structures, and they can do professional work of good quality and come up with good R&D to be able to answer this question of how to retrofit existing structures. Right. So the bottom line for us is new structures should be peer reviewed, and technologies with R&D backing should be used henceforth, and type designs should be used only if it is fully tested, only if they are fully tested. As far as existing structures are concerned, we need to do assessment. So nonlinear analysis has to be learned, and academia has to learn it first and then teach it to the others. And then strengthening has to be understood in terms of experimental work, and retrofit measures have to be quantified. And finally, all this needs to be demonstrated in pilot projects. Competent engineers alone can make the top 2 activities happen successfully. So you need to make sound appointments without fear or favor. You need to train graduated engineers who are practicing, and so continuing education will have to come in, and licensing of engineers, because subject knowledge keeps growing. People have to update themselves. If they don't update themselves, they don't have the license renewed, and so they fall on the wayside. This is essential for a nation which is trying to move its masses from the villages to the urban area. When there is a rural urban 30-70 is going to become 70-30, 70 in the urban area and 30 in the rural area. We are going to have a lot of work. All our urban areas will go up by 2.3 times the size that they are today, and we require all the structures to be built in 200% numbers than what exists today. Competence is not something that you can learn just in 1 day or 1 week. It happens ideally over the entire lifetime. If you are awake, if you are not awake, it will never happen for you. And if you are a responsible citizen, if you're taking salary from government or from any organization, I would expect that you are conscious and you build competence every day, each day passing throughout in these 5 cycles of competence development. Competence is essential because we are looking at the entire workforce. Out of these, the critical workforce that we need is urgently the artisans and supervisors who are in the base, 94% of the requirement, and the engineers who are in the top 4% here. And so we require about 98% of the people to be upgraded. Unless they have competence, it is not possible for us to say that we are going to become an earthquake safe nation. You can't gobble this mountain. You have to nibble the mountain. You have to start from one side. Don't get disheartened in the early years and keep going. Only if the nation gives priority to this for lifetime, then we can do it like other countries like Japan have done it. They give priority to safety of human beings, and so they prioritize their resources to allocate for earthquake safety in their country, which we haven't started yet. Capacity development is like knowing your mistakes and correcting your mistakes so that you are more competent and more capable in time ahead, right? Resilience is something that you would understand whenever there's an event, we are incapacitated. And if you haven't done anything in life and you're trying to help people that day, that is possible only if you know how to help, and that is called preparedness, which you may have done before the disaster strikes. But even then, it will not lift the situation too high. What you understand is if you don't do any preparedness, you won't even get there. But to go above the baseline, there is only one possibility, is that you have to add mitigation to preparedness and then only go above the baseline. And that is what we are expecting the nation to understand, that mitigation is the differentiator for safety, right? The recovery time is possible only if you do mitigation. If you don't have mitigation, preparedness will never bring you above baseline. So there is recovery time is infinity. That means you will never recover if you just do preparedness. Clearly, if you work hard in peacetime and add mitigation efforts, only then you can push this green line up and up as much as possible. So the losses during an event will be very, very minimal because of that. Once again, to who are capable need them not just to be degree holders, they need them to pass the examination and license themselves, and they should also renew their licenses after every 3 years. So today, as we are speaking, we have a large number of projects underway and we are not doing any audit. So if we start doing audit today, 5% of them in the next decade, we might be able to get this up to 100% only if we are consciously building peer review. I have the building owner, which is the first party. And then I have the planner, designer, constructor, which is the second party. And this second party is supposed to do quality control. And then we have a third party, which is a peer reviewer of all the activities, each activity separate peer reviewer, and they are supposed to do quality assurance. So this is how we see that the peer reviewers are answerable to the building owner directly and not to the quality control people, because they have to give feedback so that building owner who spends money should be able to control the planner, designer, constructor, and maintainer. This is an independent group and only then it will work. Otherwise it will not work. So this third party peer review system is not practiced in the country, except in very limited cases. There is a lot of third party peer review happening in paper. But when you look at their quality of services, 21-year-old, 22-year-old boys and girls cannot do quality assurance. They should not do, and if they are doing, they should be stopped from doing, because quality assurance should be done by those people who have at least 25 years of service in the subject, who have seen ups and downs, who have seen collapses and have seen good projects. Only they can catch the errors in the quality control people's work. If you have quality control people who have 20 years experience and quality assurance people who have 2 years experience, it's the wrong model India is adopting today. We need to stop that urgently. In professional practice, we make 3 major mistakes, and those 3 major mistakes are very clearly shown here. Error of intention is one, error of execution is the second, and error of concept is the third. When you look at these errors, how do you correct these errors? Error of intention is corrected by techno-legal regime, error of execution by licensing of engineers, and error of concept by capacity development. And this is what is the roadmap that we need. Unless you do R&D, you cannot do this capacity development, because we don't know how to build capacity of people to answer the questions, to remove the errors to be investigated and then to be understood and then to be corrected is a R&D activity. And that is where we need a huge number of people, right? Complacence has no place in this. We need to build competence, and competence has 3 components: positive attitude, skill, and knowledge. And attitude is the first one. If you have positive attitude, you learn skills and knowledge over time. If you have negative attitude, you'll never learn anything, and we don't need you for doing structural safety. And I don't think that you can save people's lives in this country. Unless you love people, you can't save their lives. So picture is very clear. You have to ask for competence, and only if you have all the 3 A, S, and K can you really say that you are competent. If you are going to be a teacher, you better have positive attitude in loads of them, because you're a people person, right? And if you are a practicing engineer, you should have skill in loads of them, because you have to implement all available knowledge. And if you're a researcher, you need to have knowledge in loads of them. And so you will be a better R&D person in life. The way forward for us is very simple. We have to make an imperfect start. 100 is the enemy of good, and best is the enemy of good. 100 is the enemy of 80, and best is the enemy of good. So we have to start with available resources, men, material, and start doing the work from one corner and slowly nibble the mountain as we go forward. Earthquake disaster mitigation is a must for India. And unless we do R&D, do knowledge sharing, multidisciplinary approach to problem solving, and partnership between national and international agencies cannot happen. If we have a poor R&D system, we will not be able to interact with international people, because we have nothing to show to them that they will be able to discuss with us, right? So I pray that in time ahead, we will recognize that the 5 elements of nature will continue their wrath on us, and we have to understand from nature how nature is behaving, and we have to conduct ourselves accordingly. Paper tigers are not required for us. You can show anything on computers, but if it is not tested, don't even talk about it. So for that, you need to understand the demand that the earthquake is imposing and the capacity that the earthquake structures are being designed for, and then only you'll be able to get the big picture right for this. India's growth is imminent, as I said. If we go with today's pace, we'll be 180 crores very soon. And if you are very excited people, we will become 250 crores. And for that many people, we are 140 crores today. We have to double all our requirements to meet that in 30 years, which is not going to be an easy task for us. Right? It's time to get into action for us. And of course, everything will look tough and difficult. Don't have to worry about destination. Make the path glorious, and eventually destination will be reached. Hard work alone will take you forward, and you need to be sharp in understanding that investing before is safer than paying later. Understand that mitigation is better than response. And if you look at India, we have the Disaster Management Act in 2005, the Disaster Management Policy in 2009, the plan in 2019, and the earthquake guidelines in 2007, but we haven't gotten started yet, right? And so it's time for us to do a proper earthquake disaster mitigation program with a comprehensive R&D backing given to that. And this is where all of us have to work together and make the country safer in the decade ahead, 2020 to 2030. You may have to walk alone. If others are not doing it, it's okay. At least you do your bit, and then eventually they will understand and they will join you. So that eventually our dream of a disaster resilient India, earthquake safe India can be achieved. So much has already been said in the classical literature, from untruth to truth, from darkness to light, and from life to eternity. We need to understand the classical literature on how to make earthquake resistant constructions, and we will be benefited significantly from that. I'll stop here by thanking Professor Sanghvi and Professor Deepa Raval to make sure that I'm here today and to share my thoughts with you on R&D in earthquake disaster management in the country. Ladies and gentlemen, thank you for your time and attention. Jai Hind. If you have any questions, of course, I don't see anybody in the audience because audience is audio off and video off. This is the old model we learned in Corona times. I've never seen my students, they got graduated and they took degrees and went away from the institute. So I'm hoping that today at least I'll see one or two faces. I request all of you to switch on their videos, please. Right. And if you're in compromising positions, don't switch on your videos. I understand. But next time around, please make sure you switch on your videos because Corona is over. You don't have to hide your head and you don't have to hide anywhere. Please come and let us all be together. Any question that you may have? Any question?
Hello. Hello.
Section. Yes. Please unmute yourself and go ahead. Yes, participants.
Hello. Am I audible?
Yes.
Vinod Vanwari
Yes, sir.
sir.
Yeah, sir. I'm from Mumbai. I'm in
आपका
teaching
वीडियो
fraternity.
कहाँ है साहब? आपका वीडियो कहाँ है?
ऑन तो किया है, लग नहीं रहा है. ऑन तो किया मैंने.
अच्छा, तो कल उसका
मैं ऑन तो किया है. I would love to.
यही है प्रॉब्लम. मैं जो कह रहा था ना कि अनटेस्टेड टेक्नोलॉजीज, आपने एक अनटेस्टेड टेक्नोलॉजी खरीद ली है. मुबारक हो. लेकिन बिल्डिंग्स के विषय में, स्ट्रक्चर्स के विषय में ऐसे ना करें.
नहीं,
करेक्ट. आई वांटेड टू रिक्वेस्ट यू. जी कहिए, आपका प्रश्न उठाइए बनवारी साहब.
प्रश्न एकदम सिंपल है कि इन कंस्ट्रक्शन वी हैव नो चॉइस. वी हैव वर्कर्स बाय default. Majority are still doing the agricultural, and very few companies are providing training. How to come over this problem? Very few companies. I hope, I don't want to name them, but this is a very critical problem in construction. We are middle order and small order companies are not providing training, sir. I visit the sites where students are under training. I don't find and whatever people are doing, they are learning by job. There are very few instances. How to solve this problem?
Yeah. See, typically what is happening is that what I noted, some of these companies have captive labor. They go to a village and then pick up people, and like that 20 villages from each of these states from which they're bringing the labor, and they stay with them and then they work with them. What was envisaged a decade ago was that we should do skill development, and National Skill Development Council was started.
Correct.
And the intent there was that slowly we will build the number of artisans for different trades and eventually they'll be accepted in practice. It so happens that the skill development is a little expensive because if somebody, a wage worker, has to be brought for skill development, the person has to be compensated for the wage. Correct. As well as money has to be spent for his or her training, right? And the way it is working right now is you go in a tractor and take people, 20 people from a village and put them on a train and bring them over to Madras, and then they go away into the construction site. In that model, this is not finding place. That you will take some of those, as such there is shortage of hands of workers, and you will take some of them who will go away for training. You must also recognize the cultural background of the country in which we have a number of festivals, and depending on which state you brought your workers from, they will go back for the festivals for that period. And every time they go back, it's 1 month cycle actually.
Correct.
And so we are typically looking at 9 months of work by the wage workers, and they cannot be taken away from their work. The people who are working on the skill development are now grappling with this, that how to give them wage. And so it's a large number of people, and so large amount of money is required. And the only hope was then the individual companies will train.
Correct.
But that model, as you have seen and confessed just now, very few companies are doing
Very
that.
few.
Very few are doing that.
Yeah.
So the alternative model that we were looking for is that we strengthen the ITIs and polytechnics in spread across the country.
Correct.
And get the younger people quickly into them. Okay. And then they can be available for construction. Nice. And it can be a formal, profession after that. This artisan profession can be formally considered to be formal after that. And their salaries also have to be reasonably, pegged. As of now, they
Correct.
are much lower than a degree holder. But if you look at other countries where the artisans need not have a degree, but they are paid at par with somebody who's going to a regular office also.
I see.
So there are changes that are required in our mindset. There are monies to be spent by various organizations, including governments. And there are changes to be made in terms of upgrading and upskilling the ITIs and polytechnics for us to be able to prepare a backdrop for creating this new pair of hands.
Okay.
They tried giving the ITIs and polytechnics to the private sector, but at some point of time, even that has really lost its steam. Yeah. So we are at real crossroads today. I agree with you. Very tough question, and we need to find more parallel track answers for this to make India safer.
So just thank you, sir.
You had one more question?
No, only just to add on it. Suppose there are 30 students doing diploma, 25 are going for degree, one is going for business. I'm a head of department at Mafatlal Polytechnic. Only 2-3 are going for a job. So the situation is becoming from bad to worst. People working with hands at site are becoming less.
Yes, because see what has happened is today the common I would say aspiration is to have a degree, and everybody is seeking a degree. But later they realize that unless you have the skill, you will not be able to get employment. And so 90% of our degree holders don't really get employment because of this problem that our colleges are not really upgrading them, upskilling them, or raising their knowledge levels. Yeah. But this is where I saw that the positive attitude was lacking in all of them, on both sides of the table, be it the teacher side or be it the government side or be it the regulator side, whichever side, positive attitude that we are actually building a nation. We are not spending money on them. We are building a nation.
Correct.
And so we need a change in approach of our minds that will really cause a positive development in this direction.
Thank you, sir.
Please continue your good work, Vanwari Saab. I really appreciate your hard work, and we are with you at any time. If you feel that we need to chat up more on this or do something for you, allow us to help you.
Yeah, I'll be in touch with you. Thank you, sir.
Thank you.
Participants, any further more questions? Even you may unmute and put up your question. Yes, sir. Please unmute.
Ronak Motiani. Ronak Motiani.
Yes, sir. Yeah, good evening, sir.
Yeah, I can see your video. Yes, Ronak Motiani. Please go ahead.
Sir, thank you, sir, for a wonderful lecture. Sir, actually, in one of your earlier lecture and also in this lecture, you talk about the licensing of an engineer, that is of P engineering and C engineering being talking about. So at this point of time, we have, I think so, Institute of Engineers certifying that, and I think so, Engineering Council of India doing that. Sir, is there any final authority that, or is it in place what we are talking about certifying agency? And if you want to do that, what are the things that we need to do for that? Or is there authorities form? That is what I want to say, for which we can appear and get it done. Or it is in process right now?
Yeah, as of now, there's no formal body to regulate the activities of engineers, right? There are societies, like you said, Engineers of India, Indian Association of Structural Engineers, like that. There are 132 civil engineering societies. And these societies are trying to help in whatever way possible from their own resources to upgrade or upskill the people. But fact remains is that unless there is a legal framework, it is not going to be binding on anybody to take any of these people, right? Now, if you look at the developed world, we are looking at licensing of engineers as a prerequisite for employment to sign on a design drawing. Now, the design drawing, if you are not a PE, you will not sign on the design drawing. Your salary can be 1/2 or 1/4 of the person who will sign a PE. So there is great motivation for you to get a PE license, and which is not there in India. So as you have seen, I have put one Structural Safety Act as one of the requirements on policy development. And that actually means that you need to have a law which says people who pass this licensing examination conducted by this organization will alone be allowed to sign on design drawings, and will alone be allowed to do investigations, will alone be allowed to provide professional consultancy services to people, right? And this way, what will happen is the large number of teachers who don't have competence are giving consultancy services will be thrown out unless they write the examination. And then the usual complaint that some of these organizations are doing business out of this will be gone, because only competent people are in the field.
Okay, sir. Thank you, sir.
Thank you, Murty sir.
Thank you, sir.
Further questions? Participants? Yes, sir. So
they are not in the
thank you, sir.
Post-corona mode. They're in the corona mode where there no questions are asked. I've seen my students audio off, video off, questions off, answers also off, but answers are all copied. When you do examinations, all answers are copied. That's our headache that we faced for 2 years, 2.5 years. But I'm glad that they're all here. Of course, it takes more time. Pratik Jaiswal, please. Aye, Jaiswal sir.
Yes, sir. Sir, what can
चेहरा
young...
दिखा दो जनाब. हमारे बचपन में गाना था, चेहरा दिखा दो, मुखड़ा दिखा दो. कहाँ है अभी? आपका चेहरा नहीं दिख रहा है.
Correct.
दिखा दो जरा.
Yes, sir. What can young structural engineers on their part do to scale up their competence?
Okay, first thing you must recognize is bachelor's degree is insufficient today. Today's bachelor's degree was yesteryear a polytechnic. Today's master's degree is one halfway down the old bachelor's degree. So what I'm saying, first thing that the young people should do is, out of the 3 things, attitude, skill, and knowledge, if you sort out your attitude that unless I spend reasonable amount of time in college and learn basics right, don't leave college. That is the first thing to do, is sort out your attitude and make it positive. Second thing is, when you go to any college, make sure you have all the skills required for advanced tools required for practicing engineering when you go outside, right? For example, a large number of students of ours don't know how to use these commercial software. If they know how to use it only for linear analysis, that is not good for you. When you go outside, nothing is linear, everything is non-linear. So you need to learn nonlinear analysis. And the third one is that you must spend good amount of time discussing the subject with your teachers, because knowledge doesn't get transferred by books. Knowledge gets enhanced only by talking with the people who know the subject. So you need to push agenda on all three fronts. So first of all, clean your heart first and come with positive attitude. Second, your skill and knowledge, you will have to make sure consciously before and after, you are a much higher, a much different person than what you were when you got started. Okay, so for those of you who are in doubt, let me say this. Whenever you don't have clarity as to what you should do, continue to stay in the college and get one more degree. Which means that if you have to go to do PhD, also do that, because eventually you have to spend 10,000 hours to know any subject. Unfortunately, large number of applicants for faculty positions come and say at age 29, come and say, I'm an expert in the subject. I sometimes feel that I should leave that room immediately. It's very embarrassing for 29-year-olds to tell 65-year-olds that I am an expert in the subject. And this is the attitude problem that we are facing in the country. And they have learned it from their teachers, the spectrum of teachers, starting from parents to neighbors, uncles, aunties, grandfather, grandmother, and the relatives and the far relatives and the teachers in school and college and so on and so on. It's a mess. So we need to sort out attitude in the country first. We need to become happy people. We need to become, smiling faces which are inspiring to others. No need to worry about all problems. Everybody has problems. There's nobody without problems. But if you can smile like Mazhar Dankot Sahab, what else do you want? One smiling face, सारा जिंदगी खुश हो जाती है, दिल garden हो जाती है. ठीक है? Jaiswal Sahab?
Yes, sir.
Yeah. So next, who's coming in next? Anybody who's shy, we can give you 1 more minute to become less shy and ask a question. Officially, I have till 5:15. Madam, looks like
Please
they've all been
participate
paid.
here.
They don't want to ask any question. They're not asking any question. See, one thing I can suggest is that if you read those 65th edition of a book, that means you're reading a wrong book. I can tell you that. Right? The 65th edition of a book which says IAS 1987, IES 1987, 1993, 2004, 2011, 2017, GATE so and so, so and so, so and so, with 1 paragraph of theory and 40 pages of solved examples. That's the wrong book you're reading. And that's why you don't have any questions, because in that book, there's only one formula with 5 variables. 4 of them are given and 1 of them has to be obtained. And that same, W is equal to 5 by 384, WL to the Q. Delta is equal to 5 by 384, WL to the power of 4 by EI. Right? 5 variables, 4 given, 5th one to be estimated. If you read such books, you will not have any questions because everything is clear and simple for you. Real life is not like that. There is no bending moment diagram that is simply parabolic. There is no structure that is simply UDL. All these are, starting points for life, but they are not the realities. Since I'm talking about R&D, I'm saying this, that don't think R&D is a major achievement. One of the mistakes our students and colleagues make is they think that they have achieved something after getting a PhD degree. Right? This is training. Jaiswal Sahab asked a question. What is it that young people have to do? You have to get trained. And if you are getting bachelor's degree, insufficient master's degree, just about beginning, and PhD degrees where you will have 5 years of time where you can learn things calmly. And that is when actually you must ask infinite number of questions to anybody and everybody who passes you. in the sense of visitors, in the sense of class instructors or your supervisor, and make sure that you got your basics right. Even after that, I confess, after doing your PhD consciously, it takes 10 to 12 years for you to learn the basic subject because you need to spend 10,000 hours. And so it's a long drawn process. Don't be under any illusion that before the age of 45, you'll become competent. Right? First 20 years is training. Next 20 years is serving. Nation will invest on you till age 45. And after age 45, if you have not done anything meaningful in the first 20 years, you are not required for the nation anyway. So it's a very, very tightrope walking that we have when it comes to competence development, when it comes to R&D. R&D is an attitude. You just should be inquisitive to know why. There are 5 questions, right? How, where, when, who, and finally it's why. R&D is all about why. And if you know why, all that will fall in place. If you don't know why, the rest of it has no meaning. It's bye-bye. Rest of it is bye-bye. Nobody is speaking, but I'm paid salary, so I have to speak. And my profession is to speak by taking money. Right? My salary for today, I didn't have a class today, Thursday off. So I have to speak.
So lovely you have spoken, very by heart. Thank you, sir.
And what is up? We have Palak Shukla. Palak.
Good evening, sir.
Good evening, ma'am.
Sir, actually, I want to know that you have indicated government policies. In government policies, one word is risk indexing.
Yes.
So risk indexing can be done for the multi-hazard or any particular one particular hazard.
No, don't complicate the problem. Make it single hazard first. Let us learn how to do risk indexing for earthquake resistance. Then we can do for wind. And then look at the 2 indices and see how we can merge and make a single index out of that. But today I'm not recommending multi-hazard risk index. Okay, I'm recommending single hazard index because we don't have people even as we are speaking today to serve the needs of 140 crores or 110 crores of people. Do we have 10 people who can do risk indexing in the country? Answer is no. Right? So that is why I'm saying don't complicate it. Make it simple. Just do for earthquake. Just do for Gujarat or just do for one district in Gujarat or whichever state you are from. Any one state.
And is there any guidelines, sir?
If you can look at the NDMA document on risk index.
Okay.
Right, go to the NDMA website and look at their publications and look for a document on earthquake risk index. That will be a starting point for you. You can build on that from then on. Okay.
Thank you, sir.
Yeah. Ronak Motiani is back. Ronak.
Sir, I have one basic question, if you permit me to ask, sir.
Yes.
Sir, you in your presentation you have mentioned that investigation, rigor of investigation, that 10,000 building, then 100 building and 1. And you said that level 1 assessment needs to be done for the first preliminary to filter out where the risk assessment needs to be done. So in that case, when we say level 1 assessment, that is where we can reach 10,000, does it mean that rapid visual survey sort of thing where hazard, vulnerability and the exposure can be superimposed by any of the multi-criteria decision making technique? And then what is that exactly mean that?
Yeah, see, rapid visual screening is level 1 is rapid visual screening. If you want to use those words, level 1 is that. But what is rapid visual screening? Rapid visual screening is a sum and substance of experience from past earthquakes. When you look at collapses of structures, you say this feature has really been the problem for this structure. And you list down all such features which are dangerous, which are life-threatening. That list of items is small. And that list is about 10 or 20 questions. If you can walk past a structure and tick off all the 20 questions, and if none of them is yes, you are a happy person. If any one of them is no, you are gone. right? That building is in red color. So we go put a sticker, red sticker on top of that building.
Okay. Thank you.
Now, what is level 2? You have to not just go walk past the building, you have to go inside the building. That means the level of details will increase in that. It's a detailed qualitative. So we're looking at other features also in level 2. What is level 3? We will just do overall back of the envelope calculation. Design lateral force is so much. What is the shear capacity of all the vertical members? Is it sufficient or not sufficient? Right?
Okay.
That is level 3. What is level 4? Detailed nonlinear analysis of structure.
Software modeling, nonlinear modeling.
And then watch the bending moment, shear forces, deflections, and then say, okay, it is safe, unsafe, and so on. Pushover analysis, time history, response history analysis, nonlinear response history analysis, all of that will come there.
So level 4 means a detailed assessment of IS 15988, that is a seismic evaluation guideline that corresponds
As
to
of,
level 4.
as of now, that's the only document, but we are significantly upgrading that document. So you might see a new avatar of IS 13935, which will have all the assessment and retrofit of structures. And we will drop 15988, but we'll take 13935 forward and add more clarity in that.
Okay, thank you.
Thank you. Deepa ji, aapka? Okay. Looks like we don't have many questions. So, but thank you to all the colleagues who asked questions. Very thoughtful.
I have one question.
Yes, go ahead, Deepa ji.
When you say that we stop, generally we stop at first information and rest of the top members, we make them non-contributing. So how to proceed further? So, for
Come
making
again.
contribution.
Can you repeat your question, ma'am?
Yes, sir. Sir, when we say generally we stop at first information and we do not let above members, those who are not still hinged.
Okay.
Hinge
I understood your question. What is happening today is the current design codes are such that if you design by that codes, all your damage will get concentrated only in the lower half. Now we need to change our design codes to such procedures in which the damage will also climb upwards along the height of the structure. Okay. So the two items to be watched are stiffness and strength. So this is what is called demand capacity ratio. You have to make sure that the demand capacity ratio of all the critical locations at all the critical locations is such that they form hinges. They are not like one of them has 0.2 and another has 1. The 1 will form the hinge. The 0.2 will never form the hinge. So you need to have all of them near 0.8, 0.9 so that eventually after the first hinge, the subsequent hinges also form one by one after that.
Okay. So optimization and.
Yes, ma'am, you were saying something? Okay, we lost Deepa ji. Ronak Motiani. Ronak, go ahead.
Yes. Sir, in continuation to the question that I asked earlier, you said level 1, 2, 3, 4. So, sir, ideally, if in ideal way, if a building needs to be assessed and followed by a retrofitting, what should be the requirement? What should be the exact under document? Because most of the documents.
If you are the owner of the building, you can do level 1, level 2, level 3, level 4.
Okay.
If you are Government of India, you will do level 1 screen off buildings. Look at how many buildings are there. Level 2 screen off many more, and then reduce the number because money available is only so much.
Okay.
So you, depending on who you are, if you are Government of India, you are using these levels for prioritizing. If you are the owner of the building, you're using these levels for understanding the behavior of the structure, behavior of the building, and then doing analysis. But very clearly, you cannot stop with level 1 and level 2. Minimum is level 3 for all structures. It is just that we have to prioritize them.
Because sir, I'm asking this question with basic that when we see a tender document of a seismic assessment, most of the things are related to NDT, and the strength assessment is a part, and majority of that report, I have a very limited knowledge, but the report which I have seen, the reports are basically based on the NDT test, that is rebound hammer UPV on the RC structural element and no further assessment. Whereas recently I was involved in one of the project by RBI, that is Reserve Bank of India of Ahmedabad. They had a very stringent document that was, I think so, more than a level 4. They expected us to design it. First was an assessment, then the design, then they even wanted execution of that and certification that you said, the closed loop design, that ensuring that whatever we have designed is being executed on the contractor side. But that was the first document that we came across. Ideally, the document is just related to NDT. So, sir, actually, document should not be NDT. Just should not restrict the assessment to the NDT.
Pardon them, my lord, for they know not what they are doing. So today's situation in India is that you have to educate your client and make the client write the tender document, and then you apply for the tender yourself. That is how the situation is in India. Right?
Yeah, that's all I'm asking, because they ask what needs to be done. You only let us know what needs to be done. We'll float that and then we'll come to the part.
Right.
Even
So,
with the
this
government,
is
even with the
very difficult situation in the country. We are facing this crisis, and I agree with you. By just doing NDT, you can't declare a building safe or unsafe. 100% guarantee on that you can't use NDT and then guarantee the building to be safe or unsafe. You need to do more on that. You need to do enough verification. One of the things that you can do is actually do ambient vibration test on the building and see what is the natural period. Do your computer model and see that it will be far away from it. And then what will you do? That means all your models are nowhere near the actual structure. You'll be off in stiffness by a factor of 2. Right? So then what you do? You need to start understanding the behavior of the various elements that exist in the structure, like the infills, and then start including their stiffnesses. Look at staircases and start including their stiffnesses, and so on. Right? So this is the beginning of a long, slow walk that we have to do. I'm praying that we can have a pilot study which will demonstrate this whole level 1, level 2, level 3, level 4, which can help others start walking on that path. And this is the revision that we are doing for IS 13935. We will talk about level 1, 2, 3, 4, and then you will be helped in the stepwise procedures for that, and the considerations that you have to use in the nonlinear analysis also.
Thank you, sir.
दीपा जी आप आ गए 2 मिनट बचा है.
Okay, sir. Yes.
So thank you,
is done.
Deepa ji,
Now,
for everything, and I enjoyed being here today. The questions were few but very insightful. So I'm hoping the others will take a leaf off, and in all the subsequent occasions, they will start asking questions. And so for that, they have to come prepared, and it will help if they can be a little more proactive in the meetings in time ahead. Thank you very much. And ladies and gentlemen, thank you for your presence here.
thank you very much from our side. I feel short to summarize your such an intelligent presentation in my own words, but we will keep in mind what you have guided us on to contribute to country by doing our fruitful research, taking baby steps, and being more proactive than what we are at present. Thank you very much, sir. And thank you for enlightening us. Thank you very much, sir.
Thank you. दीपा जी आपका voice muted hai, so I pray that
Yes, sir.
meeting is over. Okay, thank you so much once again.
Yes, sir. Sir, Sangvi sir is, I think he's not feeling well. So
No. It's fine. Please give my
sort of
respects to
from
him
many days.
and tell him,
he's
yeah,
not
I'll
feeling
talk to
well.
him again and wish him a
Ha, ha.
quick recovery. Yeah.
Okay. Thank you.
Thank you. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Good day, sir. Please stay for 1 minute. A small announcement and humble request to fill up the Google form to enable us proper naming on certificate. Please do. Once again, even though you have filled up earlier, to maintain your attendance record and prepare a proper certificate. So we will again repost the link and please fill up those who have not filled up. We have got 45 responses out of 60 plus. So please. Thank you. Thank you. Rushit will have something to announce. Rushit, please.
Hello, am I audible? Yes. Just few minute, a few time. Tomorrow is the last day of our short-term training program. So I hope all of you will attend it with all of your hearts and mind. The first session will be by Major Dr. C.S. Sangvi sir on wake-up call earthquake safe construction challenges and way ahead at 11 a.m. Then Dr. P.K. Garg will take a session on role of UAV, drone and geoinformatics in disaster risk resilience and resource mapping at 1:30 p.m. Finally, at 3:30, there will be a validatory function of this short-term training program. So that's all for today. Thank you for your participation and presence. Thank you all. Now everyone can leave and tomorrow we'll meet at exit 11 a.m. So, thank you.
Thank you, everyone. Thank you for your active participation. Recording stopped. On second, karo.